We are very excited to introduce the expansion of the 16nm Virtex UltraScale Plus FPGA to include integrated HBM memory. In a cloud-empowered world of unprecedented connectivity, we find ourselves ever thirsty for more and more computational bandwidth. We can observe this trend in Ethernet, which in 10 short years has exploded from 10 gigabit per second to 40G and 100G, and now we see 400 gigabit per second Ethernet is on the horizon. High-definition video has experienced a similar trend, evolving from 1080 to 2K, 4K, with 8K coming. For data center computation, we can observe the DSP block density in FPGAs follows the same exponential growth trend, expanding from only 2,000 DSP elements in Virtex 6 to over 12,000 DSP elements in today's Virtex UltraScale Plus. Over that same period of time, the transition from DDR3 to DDR4 has not kept up. It's clear that a new approach is needed to bridge the bandwidth gap for these next-generation applications. Virtex UltraScale Plus HBM devices expand on the industry-leading Virtex UltraScale Plus 16nm FPGAs that are available today. These new devices feature 8 GB of co-packaged DRAM via the HBM Gen 2 stacks and will provide a staggering 20 times the memory bandwidth of a traditional DDR4 DIMM. The DRAM is integrated using stacked silicon interconnect technology, the same assembly we've been using on Virtex for 3 generations now. The multi-terabits of bandwidth are enabled through an innovative hardened memory controller included in the device. The memory controller uses Xilinx standard AXI interconnect for easy integration using our Vivado design suite IP integration tools. These devices will also enable cache-coherent interconnect to processors with CCIX technology. The Virtex UltraScale Plus HBM solution is constructed using the same building blocks as the already shipping Virtex UltraScale Plus family. Pictured in the cartoon is a VU13P, the biggest Virtex UltraScale Plus FPGA today. Thanks to SSIT, assembling an HBM device is straightforward. We simply replace the bottom 2 base FPGA slices with a new HBM-enabled slice and the memory stacks. The best part is, all of the base FPGA features are already production qualified. This includes our award-winning transceivers, hard Ethernet and FEC blocks, Gen 4 PCI Express, and more. This is a very low-risk approach since only the HBM and C6 blocks are new. As mentioned previously, these devices are assembled using stacked silicon interconnect technology, the same assembly used on the base Virtex FPGA family. Xilinx pioneered this assembly back in 28nm, and it turns out we were onto something, because SSI, now called CoWoS by TSMC, has been adopted as the de facto assembly process for HBM-enabled devices from many vendors. Case in point, pictured on the left is a GPU with HBM assembled using SSI technology. On the bottom, you can see our 16nm test vehicle for HBM featuring 3 FPGA slices and 2 HBM stacks assembled using SSI. With multiple terabits per second of memory bandwidth, it's critical that the memory controller be built with ease of time enclosure in mind. Several innovations went into delivering this hard IP. First, the user interface consists of 32 AXI channels that physically extend up into the FPGA fabric. This opens up significantly more routing resources to get the memory buses into and out of the controller. Another innovation is flexible addressing, which allows any AXI port to access any physical memory address on either HBM stack. This sets Xilinx apart because it gives designers the freedom to treat the HBM stacks as one contiguous memory, or partition them as an application requires. These innovations greatly reduce data flow congestion, providing the fastest time enclosure and quickest time to market. In addition to HBM, these new devices will also include C6 cache-coherent interconnect ports. FPGAs are becoming increasingly popular in the data center for computational offload, and C6 is the logical extension of this trend. The C6 standard is not owned by any one company, and therefore enables an ecosystem of server-class processors to share memory resources with accelerators. CCIX pairs the FPGA directly with the CPU for the most demanding high-performance compute workloads. Put it all together. With CCIX, the FPGA and central processor work in tandem to create a highly scalable compute platform to tackle the most intensive workloads. In this example, we see the data enters the FPGA via a cache-coherent write from the processor. The data is routed to the nearest convenient AXI port to be written to memory. Note that thanks to flexible addressing capabilities, the designer can choose the most convenient AXI port for ease of time enclosure. The data is then written into the HBM stacks. In this case, the controller treats the two HBM stacks as one contiguous memory thanks to flexible addressing. Finally, the data is read out of the memory by any AXI port and forwarded to its destination. Again, data can ingress or egress from any AXI port, allowing the designer to choose the most convenient port for that function. So, how do designers make use of all this computational power? Vivado Design Suite has differentiated Xilinx in the marketplace by providing high-level abstractions for IP integration. This is the best way to take advantage of flexible addressing. It enables the highest FPGA Fmax thanks to Smart Connect and time borrowing. And with SDX high-level abstractions, software and system engineers can get their hands on all of this computational horsepower without being RTL experts. Virtex UltraScale Plus HBM represents the sum of many long-term investments from Xilinx. First, the UltraScale family represents a multi-node lead in FPGA architecture. It is the most solid foundation on which to build these next-generation high-end devices. Second, Xilinx has been assembling Virtex devices with SSI technology for 3 generations now. This assembly has been adopted as the de facto choice for HBM integration. The Vivado Design Suite is the most state-of-the-art FPGA design software available, completely built and delivered by Xilinx. Finally, the flexible memory controller is designed to simplify high-speed memory access from all angles, empowering designers to focus on differentiating their products with the fastest possible time to market. Xilinx has demonstrated the right pedigree to deliver next-generation technology on time, every time. And now, we look forward to delivering the most capable FPGA solution for HBM integration. Product tables and associated documentation can be found at www.xilinx.com. Thank you.